2014, a major innovation burst onto the AI scene with the introduction of Generative Adversarial Networks, or GANs, by Ian Goodfellow and his team. This breakthrough opened up entirely new possibilities for creating incredibly realistic data, from stunning images to compelling audio, pushing the very boundaries of what AI could achieve. But how do these revolutionary networks work? Let's break down the concept of GANs with a simple, creative analogy. Picture this. You're an art student just starting out, learning to paint. You dream of creating a masterpiece, something that looks like it was painted by a seasoned professional. To drastically improve your skills, you come up with a brilliant plan. You're going to create a painting, and then you'll show it to a very tough art critic. This critic's job is to decide if your painting is a true masterpiece or just a practice piece. In this scenario, you, the art student, are like the generator in a GAN. The generator's goal is to create something so realistic that it could fool anyone into thinking it's authentic. And the art critic is like the discriminator in a GAN. The discriminator's job is to examine the creation and decide if it's real or if it falls short. Here's how this artistic competition plays out. You, the generator, create your very first painting. It's not great. You're just getting started. The critic, the discriminator, looks at it and easily concludes that it's clearly not a real masterpiece. But instead of giving you a simple yes or no, the feedback is more nuanced, something like, this looks 23% like a real masterpiece. This score helps you figure out how far off you are and in which direction to improve. You take that feedback and adjust your next attempt accordingly. You learn from that feedback and try again, creating a new painting, this time attempting to make it much more convincing. The critic examines it again. Maybe it's a bit better, but the critic can still tell it's not a masterpiece. More feedback is given. With each new attempt, you get better and better at painting. You start to understand what subtle details and brush strokes truly make a painting look masterful. The critic also gets better at spotting flawed attempts because they're learning from both your improved attempts and from seeing actual masterpieces from a gallery. Eventually, something amazing happens. Over time, through this continuous back and forth process, you, the generator, become incredibly skilled at creating paintings that look like real masterpieces. You learn the subtle details that make art look truly authentic. At the same time, the critic, the discriminator, gets better and better at distinguishing between real and less convincing paintings. But because you're improving so much, you start to create paintings that even the highly trained critic has trouble telling apart from genuine masterpieces. The ultimate goal is that you, the art student, become so skilled that your paintings are virtually indistinguishable from those of a master artist. That's precisely what a GAN does. It generates data like images, music, or even text that looks so real, it's incredibly difficult to tell it apart from actual human-built creations. In summary, GANs employ two competing components: the generator, like our aspiring art student, and the discriminator, like the tough art critic. The generator tries to create something that looks real, while the discriminator tries to tell the difference between real and fake. Through this continuous improvement and feedback loop, the generator gets incredibly good at creating realistic data, and the discriminator gets remarkably good at detecting fakes. The result? The generator can produce data that is so realistic, it's virtually impossible to distinguish from the real thing. Generative adversarial networks have become a groundbreaking technology with a wide array of practical applications, particularly in generating realistic data across many domains. In the entertainment industry, GANs are used to create deepfake videos, convincingly swapping faces, or generating entirely new scenes, often for special effects in movies and TV shows. For instance, GANs have been employed to digitally recreate actors in scenes where reshoots are impossible. In the art world, GANs are revolutionizing creativity by generating new artworks that mimic the style of famous painters. Platforms like DeepArt and ArtBreeder allow users to create unique pieces of art by blending different styles, all powered by GANs. Additionally, GANs are used in video game development to automatically generate realistic textures and environments, significantly speeding up the design process. Another fascinating application is in fashion, where companies use GANs to design new clothing patterns and styles, offering designers innovative ideas and inspirations. In cybersecurity, GANs are utilized to improve the robustness of security systems by generating synthetic data to train models against potential threats. In the field of healthcare, GANs are being used to enhance medical imaging by generating high-resolution images from low-quality scans, helping doctors make more accurate diagnoses. GANs also assist in drug discovery by generating potential molecular structures for new drugs, accelerating the research process. These specific examples illustrate just how essential GANs are in pushing the boundaries of AI creativity, allowing machines to not just analyze, but also to generate and innovate in ways previously unimaginable.